Welcome to N is for Networking, the podcast for anyone trying to get their heads around the wonderful world of data networking. Networking's got tons of jargon and complex topics, and our job is to explain them in simple to understand terms. I am Ethan Banks, a network engineer who's been pushing packets around since the 90s, and with me is Holly Metlitzky, a networking professional who's much newer to networking, and we are exploring these concepts together. Today's topic comes from the audience in the form of the following question. What are the most essential topics to learn in networking as someone new? Which I looked at that question like, wow, that's actually really hard. I mean, we broke it down to 10 points though. And I guess to me, it was like big picture stuff, Holly, like what the heck is a network if we zoom way, way out? Did you have thoughts on that?
It's funny because also looking at this question, you would think that I would know the answer since I've kind of just been through all of this. And I was still like, oh, I don't even know where to start. But yeah, if we zoom all the way out and think about a network, you just kind of think of how do we get, data from point A to point B, or how do we create some sort of communication through systems at a very high level?
Yeah, I agree. It's a system that allows for communication, for data transfer. It's some collection of devices that are moving data through them, that data containing the information we care about. So just understanding that in principle is like, we're really going to talk about big ideas like that. And that, well, we got to get into more detail. I mean, we do get into more detail than that. But I mean, as a new networker, you want to start getting your head around the big picture of what's really going on. So, okay, so if we zoom way out, that's what a network is. If we zoom in a little further, what makes a network? What is a network, do you think, Holly?
I think, a network can be something as simple as two devices sending data between one another. You get to a stage where you want to zoom in and you think, oh, a network, it's got to be super complex and have a lot going on, but it can literally just be two devices.
Yeah, and that is exactly true. And there's been over history all sorts of different kinds of network. I suppose the simplest network that when I teach these topics, I'll bring up is as a kid, Holly, did you ever play with 2 tin cans and a string between them to see if you could talk?
Of course.
I mean, that's a network, right? You got a string. Your tin cans are both sending and receiving devices, and if the system actually works, you can actually hear the other person through the vibrations communicated through the bottom of the can and across that string and into the other can. It's terrible, but I mean, it is fundamentally, it's a network.
A network nonetheless.
Nonetheless, exactly right. And so really anything like that you can think of qualifies as a network. And then when we're talking about a data network, it could be as simple as a couple of different devices talking to one another. It could be two devices sharing a common wireless access point, talking to one another. That could be that strips it right down to not much left. You couldn't make it much smaller than that. Okay, so I guess the next thing we should talk about, Holly, then is what's going across the wires that interconnect our network devices. And the answer is packets. And we talked about packets in we've been talking about packets, I think, every episode we've recorded so far.
Yeah.
But I mean, I think we talk about frames versus packets in one of our episodes, and we've been digging into that concept. But I wondered if you had run into this, Holly, in your studies. Packets versus circuits, because that's really the distinction we want to make. Modern networks are packet switched networks, not circuit switched networks. Do you understand what we're getting at when we talk about the difference between those two?
So I actually had to do a little bit of a deep dive into this because, sure, I've heard about, I did electrical engineering courses. So circuits to me are, electrical circuits, which isn't far off from this.
No, it isn't. Yeah. No.
But no, we don't start at square one. We don't use circuits anymore. It's all packet based. So we ignore that whole side of it. So I had to go and look into that and be like, okay, how did we get to where we are now?
And a good example of how we got to where we got now, if you want to understand what a circuit switch network is versus packet switch, well, back in the day, you would connect two ends two endpoints that wanted to communicate to each other by actually physically connecting a piece of wire between them. And the best example I can think of is the classic telephone switchboard operator you might see in an old-time black and white picture where there's someone sitting at a desk and in front of them is a huge patch panel and they got a bunch of cables, and they would get a call in from someone on the end of the line, someone with a telephone. And who do you want to talk to? I want to talk to thus and such a number. And she would, typically it was a she in the picture, would grab the cable and plug in that person into that destination, wherever it is they wanted to talk to, and complete the circuit. Literally a wire connecting the two ends. It's a circuit. And early data networking, some of that were circuit switch networks. But Holly, I suppose you can imagine the inefficiency of circuit switch networks?
Definitely. I mean, also, not only is it inefficient, but you've now got a whole lot of human error. You plug that wire into the wrong person, and now you're speaking to somebody's grandpa on the wrong line.
And even if we're building circuits that are permanent in nature because you're just permanently connecting to endpoints as opposed to some human who's doing the switching in the middle, what we really ended up with was just, look, we need to share these wires. We don't have enough wires in the world to patch everyone together directly one to another. That's not a thing. We need a different way to communicate. So instead of having dedicated circuits where one end would talk to the other end over that dedicated line, we've ended up with packets. So now we've got a shared communications medium, a network, a physical network of wires that connect us all, and multiple messages, senders and receivers can share that network by, instead of having a dedicated circuit, we break our messages up into packets and let the network intelligently route each individual packet from where it is to wherever it needs to go. That gives us, that's the whole world runs that way now, packet on a packet, as a packet switched network. So with that technology, we've built the global internet. We've built everybody talking to everybody is pretty much that medium now.
Yeah, which is quite a crazy thing if you were around back in the day of proper, switching boards to where we are now. It's changed rapidly.
It's rapidly and dramatically, and we've been able to scale with that. We've been able to build the entire internet with that, which I suppose brings us next to the next big concept that people should understand if they're brand new to this: is what is the internet actually? Which is a funny question, because the internet is it a web browser? Is it my Wi-Fi? What is the internet? How would you describe it?
Yeah, I mean, it took me some time, even coming into networking. I knew the basics of what the internet was, of course, but when you start thinking about it, do you really know? And I mean, it's a network of networks. It's how we all connect to one another. If you think about the actual word, it's like internet. It's between two nets. So it's, if you dive into it, it's almost self-explanatory, but you think, oh, the internet, it's just, Google Chrome. I'm like, not quite.
No, yeah, and actually, right. The services that we use that we conflate with the internet isn't the internet. The internet is, you hit it right on when you said network of networks. That's right. It's in the name, internet. That's exactly what it is. And I came up in an era of networking when the internet was growing in popularity, and there were questions like, should you connect your business to the internet? How can you use it to make money for your company? And there were articles about that. It wasn't as obvious as it sounds like. Well, obviously everybody's connected to the internet. You mean there were times when companies weren't connected to the internet? Oh yeah, that's what the 90s and even the early aughts in some degree was all about. And part of my job as a consultant way back in the day was connecting people to the internet. And so to connect to the public internet required the same thing it requires today. You got to bring a circuit in that's connected to the public internet. You've got to get an address that's assigned to the thing, and then you can route your packets from your network into the internet for global routing and get that back. We take it for granted. We get it on our phones from our wireless carriers. We get it in our houses from the service providers that service our homes. We have it in our businesses and don't think of it. But not all that long ago, it was not something everybody had. It was a new and upcoming and cutting edge service. And a lot of people are asking questions like, why do I need this? So
Yeah,
a network of
I think it's
networks,
now the opposite. It's kind of how do you exist without it?
right?
Um,
We don't record this without it. The business I operate doesn't happen without it. Most of us don't watch our TV without it. A lot of us are relying on streaming services these days that all comes in over the internet, and payments rely on the
yeah,
internet. In to the point that when we had someone hit a telephone pole in my town recently, cut the fiber line that was strung across that pole, and internet was down for the town, and restaurants were shutting down. We don't have a way to accept payments. So
wow,
very likely they were using an internet-based payment gateway
yeah,
to service payments. So, all right, so we're building here. So we started with the very basics of what a network is. Now we talk about packets, and now the internet, which I guess means IP would be the next thing you want to study. That is internet protocol. Now, I know you got into IP quite a lot, Holly, in your studies.
yeah. It's quite funny because before I even quite understood what IP was, I was already trying to figure out subnetting, which is backwards. It's definitely not the way to start. Um,
Nope.
but how you do anything and how you transfer anything across a network, you've got to have a system. You've got to have a protocol,
Mhm.
which allows the data to transfer from A to B.
An internet protocol is exactly that. It's defining when we put a packet on the wire, how do we know where the packet is coming from and where it's going to? An internet protocol helps us define that and many other things. But I think the thing that's most visible to us, if we look at a packet, the thing we might initially care about the most are those source and destination addresses. Internet protocol, it's the addressing system along with other metadata. It's used to label packets so that a network knows where a packet, mostly where it's going. There's a destination address in there that tells us where this packet is headed. And we got IPv4 and we've got IPv6, and there is no IPv5. If you want to have a fun Google search, go look up
Yeah,
IPv5. There is a short story there, but
I did.
did you
I
happen to look
went.
that up?
I did because I'd never thought about it because I'm like IP4, like 6, even numbers. I
Yeah.
like that. Sounds right. But then I thought, geez, I've never actually stopped to think like, why is there no IPv5? And I did. I went to look at it, and somebody did attempt to create IPv5, but it was never accepted as a protocol,
Mhm.
because if IPv4 has some quantity limitations, and IPv6 helps to create a much larger pool of addresses. But IPv5 didn't create any more addresses than IPv4 had because it was based on the same system. So it didn't really differentiate much from it. Besides, I think it helped with correct me if I'm wrong, but I think it was a voice over IP is where IPv5 started off and launched into that, but IPv5 kind of disappeared along the way.
I don't even remember, to be honest with you. I didn't look it up. I looked it up at one point. There was a blog post a friend of mine had written about it because it was just an interesting curiosity. So if you're out there listening and you're studying IP, there's IP version 4, which is the what we call dotted quad notation, 1.2.3.4 style notation. And then there's IPv6, which is a much longer address space separated by colons instead. So they look quite different. And they're going to coexist for a long time. So if you're studying this, is IPv6 taking over and IPv4 is going away, so I don't have to bother learning IPv4? Oh, you should be so lucky. But no, that's not how that works out. V4 and V6 are going to coexist for a long time. If you're studying this, you should be learning both. Start with the IPv4, but be learning IPv6, I would say, roughly at the same time. Some of the concepts are different. The addressing systems are different. Some of the rules about a number of things and the way IPv6 operates compared to IPv4 are distinct, like similar but different. And you do need to know both, and you will need to know both for many years to come. IPv4 is not going away anytime soon. That's a whole other show. We could talk about why,
Yeah.
Pauly. But so I think the next thing then would be, as far as a new networker trying to know what to get their heads around, would be Ethernet. And to me, Holly, Ethernet, it's the most common standard used to deliver packets once they've made it to your local network. Your local network, like what's in your house, what's in your businesses, it's most likely an Ethernet network. So, dig into Ethernet. And genuine question here, Holly, in your
Yeah.
training that you've done, was Ethernet dug into? Like, did you learn about things like frames and MAC addresses and all that sort of thing?
Yeah, we did. We definitely did. I don't think, just have a basic understanding of it. But you need it. It provides the basis for most things. So
Yeah, it does. And I mean, if you were working for a service provider, there'd be lots of other transports aside from Ethernet that would be of interest to you. But the big thing, if you're new to this, Ethernet, and then right on the heels of Ethernet, Wi-Fi. You really learn wireless. So if you've got a wireless access point in your house and it's your gateway router, it's the thing that connects you to the internet, and maybe your provider provided it for you, and all you know is when you look on your phone or your laptop, you get this SSID of a wireless network to connect to, and you know what the password is, and that's as much as you know about Wi-Fi. Dig in. There's a lot of cool stuff to learn, and all kinds of businesses run Wi-Fi. And like Holly, the company you work for, Juniper, has missed wireless networking that I know is really popular in a lot of enterprises.
yeah, I've dug a lot into Wi-Fi. Not actually because that was my course of study, just because we've got a great product and I have to know the ins and outs of it. And so a lot of it has just been learning on the job, and it's really interesting. You mentioned SSID, and
Mm-hmm.
I had to try and explain what an SSID is to somebody, and it's quite funny because the random person connecting to the internet just sees a name. They're
Mm-hmm.
not
Yep.
connecting what is that like what is the Wi-Fi name that you're connecting to. They just, oh, it's just the network name. Like, well, yes, but it is an SSID, and trying to explain the difference between all the different gigahertz lines and everything else
Yep. Yep.
is a whole nother story. But it's
Yep.
it's an interesting space. I really enjoy it.
If you're wanting to get into this and you're looking at Ethernet versus wireless, one of the big differences here is modern Ethernet is switched Ethernet. Holly and I talked about that in one of our episodes where we got into broadcast domains and talking about switches, and I think it was our episode about VLANs, Holly, maybe.
Yeah.
We might have talked about that. Well, okay, so you tend to, in an Ethernet network, have a dedicated line between you and the switch. No one's competing for your signal. There's no one else on the wire but you, between you and the switch. Well, with wireless, everybody else is competing for the signal, if you will. Only one person can speak on the air at a time because you're using radio waves. If two senders send radio energy into the air at the same time, those waves will collide with each other and corrupt each other. And the whatever it is that arrives at the access point, or vice versa, is garbage, and there has to be a retransmission. So wireless, the busier a wireless access point gets and the more clients that are on them, the slower it can go. So you could have 5 bars of Wi-Fi. You look at it, like, I got all the bars. Why is it so slow? Because a zillion people are trying to get on the air at the same time to talk to the access point. That's why. And you got to wait. Or you and 3 other people tried to send at the same time. You collided, corrupted, and everybody's backed off and is waiting to retransmit, and it's just sluggish. So this is a thing that can happen in people's homes too, even where, like, if you're a gamer, you want the best performance for gaming, go wired. Get a wire plugged into the wall, into your switch. Do that. Don't rely on wireless. So you're saying, yeah, have you been there, Holly? I don't know if you're a gamer or
Yeah.
not.
I'm not a gamer, but I've been shouted at in my house to get off the Wi-Fi because somebody else is doing something more important, and
Yep.
they want to dedicate it to themselves.
Yeah, fair enough. All right, NAT is our next topic here, network address translation. Now some people might be listening to this going, Ethan, that's sort of advanced, man. What do you mean that people new to networking should understand NAT, should understand network address translation? Well, okay, Holly, so I'm going to argue that the reason I think this is important is because every network has this that's running IP version 4. And it's so super common, and it can get confusing because, okay, so here's the scenario, Holly. I don't know if you've run into this, but with IP version 4, you have private IP addresses that you can run inside your network. You're just for talking inside the building, if you will. And the Internet Engineering Task Force, the IETF, created a standard about this. They write request for comments documents called RFC documents. So the IETF publishes RFC documents, and they published an RFC that every network engineer knows about called RFC 1918. If you go and Google RFC 1918, you'll get this plain text formatted document that comes back to you, but it is going to explain about these private reserved address ranges. Any IP version 4 address that starts with 10, a bunch of them that start with 172, and a bunch of other ones that start with 192.168 all fall into this range. Well, here's the catch with the private internal address, Holly. Did you catch what the issue would be with these RFC 1918 addresses and internet communication? Make a guess if you don't know.
Well, I would go, with larger companies and larger businesses, it kind of stems into IPv6, but it's a capped amount. And also our internet, our let's say intranet and your intranet are going to be using the same IP addresses internally. So how do we communicate with one another?
Yeah. So you just hit on a bunch of things that are all true. So RFC 1918 address space for enterprises, there's a limited amount of them that are defined in that request for comments document. And so really big companies will run out. They'll burn through everything that's in there. Another challenge that Holly said is if you've got more than one company out there, and there's zillions of companies out there, obviously, and we're all using RFC 1918 addresses, we're going to be using the same addresses as one another, which would be really confusing if we're all supposed to be unique, but we're all sharing the same addresses. How do you solve that problem? I'll throw in yet another thing is, as far as internet communications go, RFC 1918 addresses are not routable on the public internet. Any internet router that receives traffic from one of those addresses, a typical configuration is that it's going to drop them. It's going to throw those away. Oh, I'm an internet router. I shouldn't see any IPv4 packet coming to me that starts with 10 dot something. Drop and throws it away. It doesn't have to be configured that way, but that's pretty common. And so what's the solution to all this, Holly?
NAT.
Now we've got network address translation. So, and in simple terms, person trying to get your head around this concept, if you've got an RFC 1918 address that's only good for internal communications, when that packet gets to your internet gateway, so that the next step is the internet, you NAT your address. You translate it into some public address that's okay for routing across the internet. There's a lot more to the story because if you're an engineer type mind, you might be going, wait, how does it know what to translate it to? And how does it translate it back? And so on. And there are answers to all of those questions. In the meantime, check out whatismyip.com. This is all one word, whatismyip.com. It'll tell you what your public address is. So if you're internal using, 192.168 something, let's say, or 10 dot something, and you want to know what your actual public address is, that's the NAT, whatismyip.com will tell you the answer to that question. Oh.
I have used it in scenarios where I need my public IP.
Yeah.
So...
All right, a couple more, Holly, for us today that I thought was important, that I thought were important. One of those is tunneling. I was hesitant with this one because it's another one of those that's like, really, Banks, you want people to think, dig into tunneling as part of their introduction to networking?
I think it's important because I didn't have it. And it's like tunneling, sure, I came across some protocols, but fundamentally, I never went through what tunneling actually is. Mm-hmm. So it's comes to a point where, I can configure tunnels, but what is a tunnel actually? So I think it's important for an essential topic because it's a common thing that's going on nowadays. So
yeah, that's the thing, and that's why I put it in here, because tunnels are ubiquitous now. So if you have career aspirations to be involved in networking, tunnels show up all the stinking time now. They're just so common. It used to be 20 odd, 30 odd years ago, like when I was first getting into this, the tunnels were like a rare thing. Like, we need to build an encrypted, secure tunnel between this business and this business because we need to share some information across the public internet. Oh, it's a big, scary thing, and we're going to make this very special tunnel to do it. Now, tunnels are the most common thing in the world. We have tunnels like I just described, but then, like I know, Holly, one of your product specialties is VXLAN, which that's a tunnel fabric.
Yeah. Which I didn't even think about it as a tunnel fabric. I just, know what it is and do it. And it's, go back to square one instead of starting at, step 5.
So here's my question to you, Holly. Do you think at this point you could describe a tunnel? Do you think you know what a tunnel is?
Yes, I think I could.
Give it a shot.
So I'd say it's kind of a way to encapsulate a packet inside of another packet to get it from one endpoint to another.
Yeah.
And I think the key thing is it's, between endpoints.
Mm-hmm.
Usually.
Yeah. No, the tunnel is between tunnel endpoints. That is, so the way to think of it is you've got two devices that form my tunnel endpoints. They are going to speak to one another. And the tunnel it's a concept. It's a metaphor for what's really going on. And you hit on what's exactly really going on, which is you're going to take a tunnel, you're going to take a packet and put it inside of another packet. And then conceptually, that's a tunnel. The packet that's inside, it's been encapsulated by another packet, is in that sense, now it's been tunneled. You don't see it. You don't know what's in there. All you see is the tunnel. All you see is traffic going between the two devices that make up the tunnel endpoints. So at the start of the tunnel, the packet to be moved through the tunnel is encapsulated inside of this tunnel packet. The tunnel packet's source and destination addresses are the IP endpoints of the tunnel, like you got a pair of routers or firewalls. And when the tunnel packet arrives at the tunnel destination, the packet is decapsulated and then forwarded on to its final destination. So I guess another question would be, you might be going, well, why tunnels? Why do I need tunnels? And there's different kinds of tunnels that do different kind of things. But like in the case of VXLAN tunnel, Holly, why are we doing it?
Well, usually you've got a very complex network. And if you know that, for example, if it's set up with pods, which maybe I'm too complex, but maybe you've got the left side and the right side of the network. Let's just go with that. And you don't want your packet to be going through every single next hop to get to, from one side to the other. But if you know that, okay, this endpoint can get to the other endpoint in one hop because it's encapsulated and it doesn't matter what's inside it, and it can be decapsulated on the other side, it's much quicker, instead of having to go through roadblocks along the way.
Well, okay, so let's disassemble that for a second, because I think you're partly right, but also not quite, because fundamentally, it's conceptually you're only going through one hop, but really, that encapsulated packet, or in the case of VXLAN, the encapsulated frame, because you're actually encapsulating an entire Ethernet frame, is going to hit every hop along the way. But it's hidden inside of that tunnel packet. So conceptually, it's one hop away. Really, it's it's going to hit whatever devices that it needs to route through, but to get between the tunnel source and the tunnel destination. And so, from a timing-wise perspective, like latency, it's going to be the same. You're going to have the same product. And maybe even potentially even a little slower, because now you've got the act of encapsulating and decapsulating on the other end, which these days that's all handled in hardware. So practically speaking, there's not any latency impact. But that is something as a network engineer, you actually need to understand, like, wait, does this switch do the tunnel encapsulation in hardware or software? Because if the chip does it, the ASIC inside the switch, all good. You don't have to worry about much. If it's software where the switch gets that packet and goes, oh, I'm configured to put this thing in a tunnel. I got to encapsulate this thing, but I can't do that on the chip. I have to punt it to my general purpose CPU and ask software to do it. Boo, super slow to have to do it like that. and that's less of a problem these days. Most of the time, tunnel encapsulation functions do happen on chip. and you don't have to worry about latency. But back in the day, that was a thing. Certain switches, I'd look at them and I'd need to build, let's say, a GRE, generic routing encapsulation tunnel. Very common, lots of use cases for them. I'd have to look, does this switch do it on the chip or does it do it in software? Because if it does it in software, that's going to be slow. Anyway, so I think we've probably gone too far down the line in tunneling, but they're so common. So VXLAN, we've talked about, IPsec, IP security. That's another very common tunnel where there's encapsulation and encryption going on. You're actually encrypting the packet that's inside of the IPsec tunnel packet. GRE, generic routing encapsulation. CAPWAP, I forget what that stands for, but it's pretty common in wireless networks it has been historically anyway, to encapsulate a packet between a wireless access point and a wireless LAN controller. That's an architecture that's still out there. You still see that. You tunnel from the AP to your wireless LAN controller with CAPWAP. And when it gets to the wireless LAN controller, there may be some policies or things that are applied to that packet before it's forwarded on to its final destination. And there's other kinds too. There's IP and IP packets. There's Geneve. That's another packet or tunneling format that's seen some popularity out there. And there's more I'm forgetting because with VXLAN, Holly, there were 2 or 3 other types that were kind of competing for supremacy, and VXLAN won. And so we kind of don't see the other ones nearly that much anymore. Okay, so I guess we beat tunneling to death, huh? What do we got left?
I've got more on tunneling, but that'll be for another day.
Yeah, okay. We should devote a whole episode to tunnels, maybe. Have some fun with that. All right. The last one I would say that's a big deal is understanding network devices. Do you get a feeling for this one?
Yeah, I mean it's what I do mostly on the daily. So switches, routers, firewalls, wireless access points. Without the hardware, you could have a network, but it would be cabling. So you really need all of these pieces to put everything together and to communicate.
Yes, and the point for you being very new to networking, trying to get your head around it, you should understand what a switch is and what a router is and why they're similar and why they're different. Start digging through data sheets and understanding what's the same and what's different about them. What's a firewall? Very common device. For example, we were talking about NAT, network address translation, a bit earlier. Firewalls are a place that network address translation is commonly done because a firewall is often the border between your network and the internet, that network of networks to which you have connected. And the firewall is the device that sits in between you and it. Even at home, what you might think of as your wireless access point, or your gateway router, but wherever your cable provider or whoever your provider is connects you at home, that's a firewall device of some kind, very likely. So
yeah, and if you log into the portal that a lot of them actually provide you with, but most people don't know about, you can configure your own security at home, your own firewall security. But that's if you wish, if you wish to play around and possibly break some things.
Yeah, if you can get into it, yeah. Or, you can go to your local Walmart or some whatever your common store is. They're going to have things like that in the electronics department, some kind of a gateway router. You might, depending on how your internet service provider is set up, you might have to ask them to use your own device. But yeah, you could do your own, put your own firewall in, and it'd probably be configured with NAT automatically for you. And then you can configure port forwarding rules. Like if you're a gamer, that could be really important to you to have port forwarding set up in a certain way, and so on. But understand what the fundamental building blocks of a network are: switches, routers, firewalls, and wireless access points, some of which can be everything in one, like that little box at home you've got that connects you to the internet we've been talking about. It's probably all of those in one thing. It's probably an AP, a firewall, a router, and a switch. It's got all the things and all that functionality. But the bigger you go, the more likely it is that those devices, that the functionality has been separated into specific devices to do that. And again, Holly, you in your world, you're going to be doing builds, I'm sure, that are, You've got switches to help build out the data center VXLAN fabric. You might be speccing firewalls. I don't know if you're getting into speccing out wireless access points or not because of what you do. It's kind of, you get into those too. Yeah.
Yeah.
But they're all separate
full
devices,
stack.
right?
Yeah, for the most part. I mean, usually if you've got a smaller use case, again, you can have a firewall that's also a router that does some switching sometimes.
Yep.
So it's really, I think initially I was quite overwhelmed because you see, wow, we have, I don't know, so many different types of switches and routers and firewalls and all these things. But it's, as long as you understand what the use case is and what do you need to get done, speeds, ports, features, etc., it becomes a little bit less overwhelming. You can play match the column and see on the data sheet, okay, cool, check the boxes, that's what the customer needs, and you're good to go. So it just gets a bit complicated when it's exactly that. You need one box that kind of does everything possibly.
Well, all right. I think we've done pretty okay here with a high-level place to help people get an idea of how information is being moved around the network, kind of the things to get your head around if you're brand new to this. And you'll find that as you begin cracking open each of these topics, there's a ton of rabbit holes and other directions you can go down in. So it's not like, Holly, you and I have been talking for almost 40 minutes here because we're really bad at keeping these as short as we had originally intended. But but you'll find that we really have shown you the tip of the iceberg for sure. And I guess one thing that we haven't mentioned is the OSI model. And we're definitely not going to talk about that today because I want to dedicate a whole episode to the OSI model and why it kind of sucks, and why it's good and why it kind of sucks. It's both. It's good, it's useful, but it also sucks and needs updating badly. And I want us to just to have an episode that you and I can go back and forth on that. But the OSI model, the was it Open Systems Information? I don't remember what it stands for anymore. But it's a 7-layer model. That'd be a thing to help get your head around some of this stuff. But again, Holly and I will devote an episode to that. And I think the last thing we could recommend, Holly, is maybe someone who really wants to go hard. There's certifications out there for people that are new to networking, right?
Yeah, I've done, I think, 8 Juniper specific ones now. And, my recommendation is definitely start with the enterprise switching and routing. That really gives you the basics of not only, a lot of them aren't really so vendor specific, as much as the entry level, associate level for Juniper, or technician for Cisco. But a lot of them just focus on the basics, and so pick a vendor, dive into one of those entry level certs, and it covers all of the things we've spoken about. Maybe not tunnels. But alongside that, I think you need some hands-on experience. A lot of them are accompanied with labs. So do the labs, understand what you're doing, because, I can have all the certs in the world and have zero understanding of how to implement any of the stuff. So,
and
get
a whole
your hands
lab goes
dirty.
a long way. Yeah.
Yes.
And you can build labs on a laptop now. You don't have to oh, you mean I got to go and buy a bunch of switches and routers and firewalls and stuff? I can't afford that. No, you don't. You can get software images that you can load in virtualization software and build a lab that way. There's a bunch of tools out there. We could devote a whole episode just to that, but there's tools like Container Lab, NetLab, GNS3, EVE-NG, all of those. Those are whole worlds you can get into where on a laptop you can build a fully functioning network lab and help you play with things and learn things, and packet sniffers like Wireshark work and break things. Yes. And you want to break things in your lab. Learn why that broke and how to fix it. Yes, that's awesome stuff.
I think my biggest learning curves have been through troubleshooting and going very wrong to go very right. So highly recommended.
If you didn't break things, there are things you won't learn because there are things you have to learn that'll only become apparent to you when things aren't working. That's exactly. Yes. Success comes through failure in this circumstance.
Yeah.
So again, back to the certs thing. There's a ton of them out there, but 2 core ones that that Holly and I know a little bit about. Juniper Network Certified Associate, JNCIA Junos, in the routing and switching tree. You said enterprise routing and switching, Holly.
Yeah.
And I agree. That seems like the right place to start because there's a bunch of specialized tracks you can go down. But for the
Yeah.
basics, enterprise routing and switching is a good way to go. Cisco has 2 entry-level certs. The very, very earliest one, or the bottom of the ladder, if you will, is Cisco Certified Support Technician. And then what builds on that is their Cisco Certified Network Associate, the CCNA. And there's tons of books out there and tons of YouTube videos out there. And there's lots of sample lab exercises and study groups and Reddit subs and so on. All kinds of resources out there that you don't have to spend tons of money to get going on this. You can, most of the virtual lab resources we were just talking about, those are free platforms, and you can get free images from vendors that you can boot up in your lab and start playing around with stuff. So don't feel like it's a sinkhole of money. It can be. You can spend as much as you want, but on training and oh man, training classes can be thousands, but you don't have to go that route at all. You can really start playing with this stuff on your own and learn things for free. And so, you said you have 8 certs from Juniper?
I think I'm on 8 now. I mean, I've got a bunch of missed certifications. I think 3 there. I've got a security one. I've got a plethora,
Beast. Okay. Wow. I used to be that. I don't have any certs right now. I got burned out on them. I went all the way up through CCIE and Cisco Land, and that was kind of the last one I did. I held on to that cert for 9 years and then just gave up recertifying because I kind of didn't need it anymore. Yeah. It's really hard. So I let it go. But anyway, hope that helps you with essential topics. We overcooked. This should have been 2 episodes probably, but you got one big one. You can let us know if you like the length of these. Would you rather these be short? Holly and I were thinking these were going to be really short, 10, 15 minutes, crank them out kind of thing. And all of a sudden it's like we're coming up on 45 minutes here with this conversation. Do you want us to do longer episodes or shorter episodes? Or do you have an opinion? Do you care? Let us know. packetpushers.net/follow-up. At that page, packetpushers.net/follow-up, there's a form there. Just find the N is for networking on the drop-down list, and it'll get right to Holly and I. It goes right into our Slack channel that we monitor when we plan the shows together. And we'd love to hear from you. What else do you want us to cover? Is the show too long, too short? What do you think? We love your feedback. And thanks for listening to N is for Networking today. I've been Ethan Banks, again, along with Holly Metlitzky. And if you have, again, those topics you want us to cover, send us that message. We have a huge topic list already, and we will add your question to it. And by the way, if you're new to the whole world of Packet Pushers, that Packet Pushers is a podcast network, and Is for Networking is just one of 12 podcasts that we have on the podcast network. Lots of other podcasts you might want to subscribe to. Maybe you think wireless networking is super cool. Well, yeah, we got Heavy Wireless is a podcast. That's host Keith Parsons. Keith is a trainer, instructor, book author, and heads up the Wireless LAN Professionals Conference that runs around the world. He's a great host, knows everybody that's anybody in networking. So go subscribe to his podcast, Heavy Wireless. Maybe cybersecurity you think is going to be your thing. Great. We have a show called Packet Protector. Go subscribe to that, etc. Just search for Packet Pushers anywhere you get your podcast, and you'll see all the shows that we have to offer. And just remember, networking isn't hard. Other people figured it out, so you can too.